Welcome to the Explainer. Let's just dive right into it. Today, we're building a definitive, practical selection manual for cable trees. We're zeroing in on managing heat and optimizing the environment for your sensitive data cables. Look, if you're designing or upgrading a facility, picking the right support system for your cabling, it's honestly one of the most consequential decisions you're going to make. Let's get to it. Here's our roadmap for today. First, the heat and performance crisis. Second, comparing the 4 major trays. Third, the special mission of ladder trays. Fourth, a 10-rack sizing drill. And finally, international standards in manufacturing. Okay, part 1, the heat and performance crisis.
Look at this number, 4 to 8 degrees Celsius. When you're running sensitive infrastructure, we're talking Cat 6A or fiber optics. This isn't just some random data point. It's literally your network's lifeline. The data explicitly highlights that operating even a few degrees too hot actually increases resistance inside the copper, which degrades signal integrity and causes data packet loss. So this specific 4 to 8 degree margin directly dictates your channel performance and the overall service life of your cables. It is literally the difference between optimal transmission speeds and totally premature hardware failure.
Think about a solid tray under full load. It runs significantly hotter, right? The complete lack of convective airflow acts as a massive performance drain because it just traps the heat generated by those dense cables right there inside the enclosure. But swap that out for a perforated tray, and that convective airflow naturally circulates through engineered openings in the metal. That's what keeps the environment those critical 4 to 8 degrees cooler. And that convective cooling is exactly what protects the delicate lifespans and performance metrics of your fiber and Cat 6A cables. Moving on to part 2. A comprehensive comparison of the 4 major trays. Knowing exactly which tray to use and when to use it is the absolute core of building this practical manual. We're comparing 4 types here: perforated, ladder, solid, and wire mesh across 7 crucial engineering criteria. We're talking airflow, physical protection, EMI shielding, weight capacity, installation speed, maintenance access, and aesthetics. And when you lay it all out, a very clear picture emerges. Perforated trays totally dominate data routing because they strike this perfect balance. They give you robust physical protection from impacts while still allowing that crucial convective airflow we just talked about. But, they aren't the only tool in the box. Solid trays lack airflow entirely, sure, but they win big when your specific application scenario demands maximum EMI shielding to block outside signal noise, or if you just need complete protection from dust and moisture. Wire mesh, super lightweight, incredibly fast to install, and allows for maximum airflow and easy maintenance, but yeah, it offers minimal physical armor. So choosing the right one really just comes down to matching your specific application scenario against these precise engineering criteria. Okay, part 3, the special mission of ladder trays. Now, if your application scenario involves routing large diameter data cables or heavily armored ones, those perforated trays actually need to step aside. In these heavy-duty situations, the ladder tray steps in as the absolute correct engineering choice. They provide maximum structural support and the immense weight-bearing capacity you need for the added girth and heavy armor of those specific cables. Plus, because the ladder rungs are widely spaced, they do all of this heavy lifting without trapping destructive heat. It's a win-win. So, looking at all these engineering criteria, the strict temperature limits, and these highly specific application scenarios, it naturally begs the question, right? How do we actually take this theoretical matrix and apply it to a live physical data center layout? Let's find out in part 4, a practical sizing drill for a 10-rack row. Walk through this sizing process with me for a second. If you're tasked with sizing a perforated tray for a 10-rack server row, it's a strict 2-step process to get it right. Step 1, you have to accurately assess your total cable volume for those 10 racks. You need to know exactly what is going up into that overhead space. Once you have that precise volume, step 2 is entirely non-negotiable. You strictly apply the IEC 61537 fill ratio guidelines. In the real world, this usually means leaving a significant chunk of the tray entirely empty, often capping your fill volume at 40 or 50%. You can't just pack the tray to the brim. Adhering to these specific IEC fill ratios guarantees that there's enough physical, empty space left over inside the tray so that convective cooling can safely happen around all your active cables. And finally, part 5, international standards and manufacturing. Reputable manufacturers like Xinma, for example, anchor their entire production lines in rigorous international standards. Whether it's cable tray systems, busways, seismic bracing, or intelligent cable management, we're talking about strict compliance with IEC 61537, NEMA VE1, BSEN 500085, and GB 31251. And this matters deeply because these components aren't just used for isolated data centers. These validated application scenarios extend way out into complex rail transit networks, massive industrial plants, and really dense commercial buildings. Having certified, standards-compliant hardware ensures your infrastructure is legally sound and functionally optimized, no matter which of these high-stakes environments you're working in. As we wrap up this practical manual, I want you to take a hard look at your own infrastructure and honestly ask yourself, are your current solid trays silently cooking your critical fiber optics right now? Understanding the exact differences in these tray options and their application scenarios is the very first step to stopping the heat drain and saving your network. Thanks for joining this explainer, and keep building smarter.